I'm going to do day 5 transformation notes, and they're fairly short tonight, so let's just jump in. So if you have two figures, they are considered congruent if there exists a series of rigid motions which maps one onto the other. Okay, so that means rigid motions. So the ones that we have learned this year are translation, reflection, and rotation. Okay, so when you're doing rigid motions, remember that they preserve distance and angle measure. That's why rigid motions create congruent shapes. Okay, so when we're talking about an original figure, that's your pre-image, and your image is after it has undergone the translation, reflection, or rotation. What's in front of you are a bunch of rules that you have to make sure are memorized, that we did memorize back when we did the unit, so please make sure you go back and refresh your memory. Remember, when you're rotating, you're always going counterclockwise. That's a positive rotation. For negative rotations, you're going clockwise. So for every positive rotation, there's an equivalent negative, okay? And for these rotations, a rotation of 90, you take your coordinate, and xy becomes negative yx, so the coordinate 2, 5 becomes the coordinate 5, 2. For a rotation of 180 degrees, you negate them both, so this becomes negative 2, 5. And for a rotation of 270, you flip and negate the original x, so now you get negative 5, negative 2. Okay. When we did rotations, we also talked about rotating. So those rules were all about the origin. When you rotate not around the origin, like this one, you're rotating point A around point B, so B is your center. And if you're rotating 90 degrees, remember that it creates 90 degrees. You can use the idea of perpendicular. So if I were to actually find the slope of AB, do that first. I can do that by counting. On my paper, that slope is 2. So for a 90-degree rotation, you're rotating using perpendicular ideas. So the perpendicular slope is negative 1/2. You're going to use that slope and count from point B. Now remember, if you're going 90 degrees, you're going to go counterclockwise, so it's going to go this way. Okay, so now I'm going to count using negative 1, 2. Instead of going down 1, right 2, I'm going to go up 1, left 2. Okay, so that's your new coordinate, 0, 2. For rotational symmetry, if a shape has rotational symmetry, the order is the number of times the figure will map onto itself in a 360-degree rotation, and magnitude is always the smallest angle that is needed to map the figure onto itself. And we calculate magnitude by doing 360 divided by the order. Okay. Now the rules down here for reflection, dilation, and translation. Remember, when you're reflecting, you're flipping it over the x-axis, y-axis, y equals x, y equals negative x, or through the origin. And again, these are your rules that you have to make sure you memorize. So when you reflect in the y-axis, you negate the x. So this point becomes negative 2, negative 5. When you reflect in x, you negate the y. So this becomes 2, 5. When you reflect in y equals x, you literally just flip your coordinate. And y equals negative x, you flip your coordinate and negate both parts. Okay, so that's what those would be. When you reflect through the origin, you negate both. So you get negative 2, positive 5. Okay. When you dilate, remember, dilation is not a rigid motion because it does not preserve distance and angle measure. Or I'm sorry, it doesn't preserve distance, which means your image and your pre-image will not be congruent. But for a dilation, you're going to multiply. So in this notation, this means dilate around the origin or about the origin. And then 2 is your scale factor. So in this case, if you're dilating the coordinate 2, negative 5 with a scale factor of 2, you're going to multiply each part of the coordinate by 2, and you get 4, negative 10. When you translate, you're adding. So I think of t kind of looks like an addition sign. And in this case, you're adding negative 3 to the x and positive 10 to the y. So this coordinate becomes negative 1, 5. So I kind of said this in the video already, but a transformation that is not a rigid motion is a dilation. Now, how do I know that? Because distance is not preserved, so the shapes will change size. Okay, remember they'll get bigger or they'll get smaller. Okay. Now, if I were to put two or more of these transformations together, it's called a composition. So sometimes more than one transformation is used. In composition notation, remember that it is written right to left. So you're going backwards when you do a composition. So in this picture, it says state the transformation that took place in the image. It should say above, in words and symbols. So when you're looking at this, the pre-image is this triangle right here. This is showing you that there was a rotation, and it's a 90-degree rotation. So we're going to say rotate triangle ABC around center D at negative 90 degrees, or you could say positive 270. And then after that, you're reflecting over, and it's line L in my picture. So that's it in words. Now remember that you have to actually write it backwards as well. So when I do this, reflect over L is composed with a rotation around center D, negative 90 degrees, and it's triangle ABC. Okay. Again, I know it's negative 90 up there as well because you're going clockwise. Okay. So when you're doing a transformation, you're always going backwards. So in this case, we're going to reflect over the x-axis first, then we're going to translate 2, 6. So my original coordinate is 2, negative 5. I'm going to reflect first over the x-axis. So remember what that was. You have to negate the y. So this becomes 2, 5. Then I'm going to get a double prime by translating 2, 6. Okay, so I'm going to add 2 to the x and add 6 to the y, and I get 4, 11. Okay, this next one, we're going to reflect over the y-axis first, then rotate 90 degrees. So my coordinate is 2, negative 5. I'm going to reflect in the y-axis. So my new coordinate, I negate the x, so I get negative 2, negative 5. Then I'm going to rotate 90 degrees. That rule on the front says the net point negative 2, negative 5 becomes 5, negative 2. And that's what you would get for that. Okay. Last one. Now this one's 3, so we're going to translate first, then reflect, then rotate. Okay, so my coordinate is 2, negative 5 again. Let's translate first. So I'm going to add negative 3 to the x, add positive 2 to the y. That's a prime. Now I'm going to do a double prime, which is reflect over y equals x. So I'm going to flip them both. Now I'm going to do triple prime, which is rotate 180 degrees. So for that one, now our new coordinate becomes 3, 1. Right? Negate the x, negate the y. Okay? Now this one, let's actually plot these. So P is 2, 1. Q is 4, 1. R is 4, 3. Okay, so this is my original triangle. Pretty tiny. It's saying find the next triangle under the following composition. So again, go backwards, reflect first, then translate. Okay, so I'm going to take my original coordinates and recopy them. So the first thing that they want is reflect over y equals x. So that rule says you flip your coordinate. So these are my new points. Okay, so let's plot those and make sure it looks right. So I'm going to plot the coordinate 1, 2, 1, 4. These are primes, P prime, Q prime. R prime is 3, 4. Okay, so remember the line y equals x is that slanted line that goes straight through the middle here. So it looks appropriate. Okay, now we're going to do the last part, which is translate. So we're going to translate -3, -3. So we're going to add -3 to both parts of the coordinate, and you get the following. And then we can plot those. So you can see in this picture, I know it's really tiny, but all three triangles stayed the same shape and size. So they're all congruent to each other. And it does look like it was moved left 3, down 3. Okay, so that completes the notes. So hopefully you fill them in, and we'll see you tomorrow. Bye.